Hey you guys, welcome back. Today's lesson is going to be section 9, topic 5 on measures of center and also the shape of distributions. So let's go ahead and jump right in. So the first thing we're going to look at is what the different measures of center are. So data displays can be used to describe the following elements, which is the center, the shape, and the spread. So today we're just talking about the center and the shape. The spread is going to be in the next topic that we cover. There are 3 common measures of center. The first one is the mean, and that is the average of all the data values. The second one is the median. The median is the middle value between the data as long as it is in order from smallest to largest. And finally we have the mode. The mode is the most frequently occurring values. Okay, so let's go ahead and jump right into an example. Mr. Gray gave a test on a regular school day with no special activities. The scores are listed below. So here is the data set right up here of the scores that those students got on that test. The dot plot for this data is as follows. So they made a dot plot of the distribution of the scores. If you notice, there's 2 dots for 60 because there were 2 students who scored a 60. That's just a little refresher for you on dot plots. 3 dots for 70 because we had 3 of those in our data set, so on and so forth. So first question is, looking at the dot plot, what do you think is the value of the median? Well, if we use the dot plot, we can basically count from the outside into the middle and find out where the points are, what the median is for that for this data set. So we have 2 here, they cancel out. We have 3 here, they cancel out, and then we have 4 scores under 80. So if I were to count from left to right, that would be 1, 2, 3, 4, 5, 6, 7. And then the other direction would be 1, 2, 3, 4, 5, 6, 7. Okay? So what we have to do here actually is we have to take these 2 middle values and we have to average them to get the median. So the median here is going to be 80 plus 80 divided by 2, and that comes out to 80. So we have 80 for our value of our median. And then what is the value of the mean? Well, if you added up all the data points individually one by one and then you divided them, you would basically be finding what the mean is. Another way you can do this is you can look at the actual dot plot and decide that since there's the same number of 60s as there are hundreds, that we can cross those out because they won't affect our average because they cancel each other out in terms of how far away they are from the middle. And then the same thing is true for 70 and 90. You could just cross these out because there's 3 and 3 of each of those, so they cancel each other out in terms of their distance from the middle. And then finally, you have this point and this point you can cancel, and all you have left then is going to be 80 and 80. And if you average those together, you're going to get 80 for the mean. Another way you could have done this was you could have proven this by going back to the data set, and you can just add up all the values from the data set and then divide them by the number of points that there are, and you would end up with the same value. Okay, next question is, why is it important to know where the center of the data is? So for a situation like this, knowing where the center is would help Mr. Gray if he were to make like some chart like with his scores. He would be able to easily identify how most of the students did on the test. So that's something you can put here. In general, just knowing where the center is it helps you to know what the average is of whatever the data is that you've counted. So we're just going to put, it helps to easily see how most students scored. Okay, and then I'm going to roll this up because there's one more paragraph here, and it says, the shape of the dot plot also gives important information about the data set's distribution. The data in the previous dot plot is symmetrical and it follows a normal distribution. And what do you notice about the shape of a normal distribution? Well, I kind of drew all over that one, so I'm going to just go ahead and draw another one for you. In general, this is kind of what that last one looked like, right? It was 3 dots here, 4 in the middle, and then 3 on the next one, and 2 on the next one. And so, in general, what you can say about the shape of this distribution is that it kind of looks like it goes up, and then it comes back down. And generally what we call this is we call it a bell curve because it's kind of shaped like a bell, okay? So it is bell shaped. That's going to be important as we go through the next couple of example problems because they're not going to look like bell shapes and you're going to be comparing the shapes of the data and figuring out what that means. So let's turn the page. This note set today is only 2 pages. And if I turn the page, the next thing I see is a let's practice problem. It's Mr. Gray again, and it's a similar type of problem. He gave a test the day after a basketball game against the school's rival, and the scores were as follows. So the reason they're telling you this information at the top is because they're trying to add a little bit of narrative as to why the scores that are shown here are going to be different than the ones you just saw. Okay, so it's the same students, it's the same teacher, it might be a different test, but this is what the scores looked like when he gave the test this time. Now, of course, there could be other reasons for this, but you can generally see that looking at the dot plot, it looks like more students actually they had like a lower score. They did worse on this test than they did on the last one. Now, it could have been 2 different tests on 2 different kinds of material, and maybe the last one was a little easier and this is something more complicated. Or it truly could be due to the narrative they tried to give you at the top, which is that it was the day after a basketball game versus the school's rival. So I think what they're trying to say is that maybe kids, like most of the kids in his class went to the game and they stayed out late and, they didn't study for the test, and that could be the reason why the scores are lower. That's just one plausible explanation. There could be others. So let's look at the first question. It says, what is the mean and median of this data? So if we're looking for the median, we're going to start on the outside and count in. So this cancels, these 2 cancel, and then this cancels. We're now here, so this cancels. I'm sorry, I'm up here. This cancels, this cancels, this cancels, and this cancels. And then we have this one and this one, and we're just left with these 2 points right here. So we're going to average to find the median. That's the middle of the data set right there. So it looks like the median is 75. And then if we were trying to find the mean, I'm going to prove this one a little differently. I'm going to go ahead and just add all the values up, and then I'm going to divide and see. I want to see if we get the same result. So that's going to be, let's see, 1, 2, 3, 4, 5 65s, and 1, 2, 3, 6 70s. And we have 4 75s, because I'm thinking the average is actually going to be a little less than 75. It's not going to be at the same point as the median. What did I just do? 75. So we have 4 80s. We have 1 85. We have 2 90s. Okay, so now we have all the multiples that we can add together. So 325, 420. Plus 300, plus 320, plus 180, plus the single ones, which is 85, 95, and 100. That was the sum of all the scores. And how many points are there? Let's see. 6 and 4 is 10, 14, 19, 20, 21, 22, 23, 24 points. So we're going to divide that by 24. Oh, and the average came out to 76.41. Okay, so 76.041, sorry. Okay, so it actually looks like the mean of the data was pretty close to the median. What measure is more appropriate in order for you to measure the center? Is it the mean or the median? So when the data looks like this, when the data is skewed right, what we mean by that is we mean that most of the data is over here on the left, and the average of the data is being skewed, it's being pulled to the right. So that sort of makes sense with what we just calculated, because the mean, the average of the data, was a little higher than the median. And the more higher scores that students would have earned over here, the higher the average would have been, okay? So if some of these students had gotten higher scores, this average would be higher, and so the data would be being pulled that direction towards that higher average score. So a more appropriate measure of center here, when the data is skewed to the right, is to use the median, because what you're looking for in terms of the center is where most of the values are. And it looks like most of the values are actually closer to where the median is, not actually where 76 is. So the median would be the answer here. Next question says, does the data set have a normal distribution, why or why not? Well, if you look at the shape here, it looks like it starts pretty high, and then it kind of goes down. And if you look at that curve that we just drew, it really doesn't look like a normal distribution, because remember, in a normal distribution, if I draw a little graph here, you have low, then high, then back low, and it kind of looks like a bell, okay? So that's a normal distribution. The one that we have here, it looks like an incomplete normal distribution. In other words, if there were some more values over to the side here, and then there were more under this curve, and then it would look kind of more like a bell, then yes, I could see it being a normal distribution. But this one's not. This one is not a normal distribution. Instead, we're going to describe the distribution or the spread of this data by saying that it is skewed to the right. So it's skewed right. And the reason, again, that we're saying it's skewed right, you might be tempted to say it's skewed left because it looks like all the data is kind of over on the left side of the graph. You got to abandon that rationale, abandon that thinking. It's skewed to the right because there's a couple of scores over here that are making the average of the data be pulled more away from the median, okay? And then the next problem we're going to do, I'm going to just give you a spoiler right now, a spoiler alert. It's going to be skewed to the left, and you'll see what we're talking about. So let's scoot this paper over. And question 2, the triad over here, it says Mr. Gray gave a test the day after a midweek early release day, and the scores were as follows. So once again, they're telling you this information up at the top here because it might give you a clue that explains what happened with this data. It might be giving you a clue to say why the scores look the way they do for this data set. So we have a couple of low scores, and it looks like a lot of 90s, a lot of hundreds, okay? What value do you think will be smaller this time, the mean or the median? Well, in our last example, when the data was skewed to the right, the mean was greater than the center or the median. So I think what's going to happen here is I think that the mean is actually going to be less than the median score. And the reason I think that is because I think these couple of stragglers over here who didn't score so well, they're going to be pulling the average down, okay? If these low scores you see right here had gotten better scores, then the average for the whole class would improve, if that makes sense. So let's see, I think that the mean is going to be smaller than the median in this case. Next question says, consider the dot plot. So here's a dot plot of this data, and it says, which measure is more appropriate to find the center, the mean, or the median? Well, I think, again, that the measure of the center, where most of the data is going to be better described in this case by finding the median of that data. What is the middle? Because the middle is going to put you somewhere inside this cluster of data right here. The shape of this distribution is blank blank. Well, if we draw a little curve here, it goes up and then it goes back down, and that's different from this one, which was skewed right. Instead, this one is skewed left. Oh, you can't see that. Okay, let me scroll that up. Okay, this is skewed left. And we're calling it that because these couple of scores pulled the average down. So they skewed the data to the left. If those scores didn't exist, the data wouldn't be skewed. It would all be clustered over here because these scores would have been higher. For a normal shaped data set, let me scroll that up so you can see that. A normal shaped data set, the best measure of center is blank. And for a skewed data set, whether it's skewed left or skewed right, the blank is better. So I think we pretty much established here that the mean is better when you have a normal distribution because the mean is going to be pretty close to the center. And then in a skewed data set where it's skewed left or skewed right, the median is going to give you a better description of where the center of the data is. Okay guys, so that's going to be it for this lesson. Attached to the Google Classroom posting for this is going to be some practice problems from Algebra Nation that are kind of similar to the ones that we just did. So you're going to have 2 scores for this lesson. The first one is going to be you uploading a picture of your notes, just like we did before. And then instead of me assigning you like a Delta Math or something, I'm going to have you print out or do the practice problems that I'm going to post separately, and I want you to upload a picture of those as the practice problems for this lesson. Okay guys, so I hope that was a super helpful lesson for you about measures of center and the shapes of distributions. If you have any questions or you need additional help, please feel free to come to the office hours that are on Google Meet. I will be live in those Google Meet rooms for the entire 3 hours for office hours. Those are on Tuesdays and Thursdays from 10:30 to 1:30. And if you need help in the meantime, feel free to send me a message on Remind or send me an email or something like that, and we can link up and kind of see if we can work through the issue. Okay, great. Have a great day, guys. Thank you so much.